Myself, Dr.K Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. We are going to continue the before problem, how to solve. In before class, we learned or we studied or we discussed how to locate eye centers. Locating the eye centers, we need the number of links. After the number of links, we have to calculate the number of eye centers by using the formula that is n equal to n minus 1 by 2. So, as we know already, it is a 6-link mechanism. For a 6-link mechanism, the number of eye centers are 15. The number of eye centers are 15. Okay. So, the number of eye centers are 15. Now, how to locate, what are the eye centers are completely? From this table, the table gives what are the eye centers are. Combination of eye centers with respect to various links. If we consider the combination, link 1 having 5 links combinations, 5 eye centers. Link 2, 4 eye centers. Link 3 having combinations, 3 eye centers. Link 4, 2 eye centers. Link 5, 1 eye center. And link 6 finally is 0. But one thing, link 6, even though combination doesn't have, but it is having a combination with link 1. That should not be forgotten here. So, eye centers of 5, 1, 1, 5 or 5, 1, both are same. But according to the rule of the notations which was given by some of the authors, we follow the notation in ascending order. That ascending order is that 5, 1, instead of calling as 5, 1, we call it as 1, 5. 4, 1, we call it as notation, the notation of eye center 4, 1 is 1, 4. So in an ascending manner, we will notate the eye centers. Now, very important thing is that after knowing all these centers, we have to mark the location, whatever required eye centers. In this configuration diagram, we did not locate all the eye centers. Let us, how many eye centers are left out, we'll check it. Link 1, 2, 1, 2 combination. 1, 2 is marked. 1, 2. Next 2, 3. 2, 3 eye center. 1, 2 eye center. Next 2, 6. 2, 6. Next 2, 4. Next 1, 3. 1, 6. 1, 3. 1, 6. Coming to 4, 5. And 4, 6. Wow, 4, 6. Next 1, 4. 1, 4. 3, 4. 1, 5. 3, 4. 1, 5. 5, 6. Next, any eye centers still we miss it to mark it. 1, 6 already marked here. So 4, 6. The leftover eye centers are here. 2, 5. 3, 5. 3, 6. 3 are left. 12 eye centers are marked in the mechanism, on the mechanism by using Kennedy's theorem. Now, remaining eye centers also, if it is required, we have to mark it. Otherwise, it is not required. Now, these eye centers is feasible or not? We have to check it first. This 2, 5 is there. This 2, 5 is the combination of how to locate 4, 5 and 2, 4. 2, 5 is the combination of 2, 5 is the combination of 2, 4 and 4, 5. And one more combination is that 1 5 and 1 2. 1 5 1 2. How to mark it? This is 1 2 and it is 1 5. So join 1 2 1 5. We'll see what will happen. Next 2 4 4 5. Where is the 2 4? Shall we know 2 4? Yes, 2 4. 2 4. Where it is? 2 4 and 4 5. Join these two combinations. This is the eye center of 2 5. Okay. Thus we can mark 3 5 also. 3 and 5. It is the 3 5. Again, you can with combinations we can mark it. But one thing is that whatever, how much it is required in order to calculate the unknown velocities and accelerations. And unknown velocities, both linear and angular velocities of a link, of the links, but not accelerations. Now, after that, from the configuration diagram, after locating eye centers, we have to measure the distances from required eye centers. What is the required eye? What are the eye centers? I13A. I13 to point A, you measure the distance with the help of a scale. That distance comes under 840 millimeter. That 840 millimeters is equal to 0.84 meters. Next, I13 with point B, you measure this distance. That is 1070 millimeter. That is 1070 millimeters. That is 1.07 meters. Next, I14B. Where is I14B? With the help of this is I14 and point B. This I14B you measure it. That is 400 millimeters. This was already given in the data. That is the distance from. That is the distance of BE link. Let us go back. The link length BE 400 millimeters. So if we measure it also I14 to B, we got it as the distance. This I14 to B, that is 400 millimeter. That is nothing but link 4. Next, I14 with C, that is 200 millimeter. It was given, that is the distance of EC. Now 1314. Next is 15 combination. What is the I15? Where is 15? I15 with respect to C. That is I15 with C, 740 millimeters. That is 0.74 meters. Next, I15 with combination. I15 is the common eye center with the C and D. So, with the D, ID. This D, I15D is 500 millimeters. That is 0.5 meters. We have to keep aside those values after measuring. You can measure I13, you can measure I14 to I12, I14 to C. You can measure and keep it aside because what is required we have to know it. How can we know only these three eye centers distances? It comes by practice. By practicing 3 to 4 problems, you can know it. What is required, what are the required eye centers are. Let us see whether this data, the way we measured the data is useful or not. Now we want velocities of points B, C and D. Velocities of points B, point C and point D. This is point B, it is point C and it is point D. That's why we found out this point B is combined with, what is the point B is combined with eye center, this AB link. That link 3. Link 3, where it is rotating, what is the eye center for link 3? 2, 3 is there, 3, 4 are there. 3, 4 also there. But there is another, neither fixed nor permanent eye centers. That is 1, 3. And similarly 1, 4 also. And one more thing, 1, 5 also. These are neither fixed nor permanent eye centers. While solving the problems, yes, I got it. While solving the problems, we need the distances from neither fixed nor permanent eye centers. So these 1, 3, 1, 4, 1, 5 are neither fixed nor permanent eye centers. You may ask, what about 1, 6? This 1, 6 is at infinity, so we will not touch it. Okay, maximum it will not be useful because it at infinity radians. What is the value for infinity radians? So that means infinity means we don't have exact location. That is the meaning. Okay, that's why what is the radius of the straight line? The radius of the straight line is infinity. Why it is infinity? No exact location radius, straight line. All right. Similarly here, that's why we touched only 1, 3, 1, 4, 1, 5. This I13, I14 and 1, 4, 1, 5 are comes under the category of neither fixed nor permanent eye centers. Now, relationship, let us begin by using the angular velocity ratio theorems or linear velocity ratios theorems. The linear velocity ratios theorem, this AB link having common eye center, link it with this 1, 3. The angular velocity of the link, that is angular omega AB equal to, what is that omega AB is constant, no? That is VA by I13 to A distance, VB by I13B distance. VA by I13A. VA we know. What is that VA? One value to be known. Another value can be found out. This VA is calculated with the given information. What is the given information is the link OA is having the constant speed of 120 revolutions per minute. That is omega OA equal to 2 pi n by 60. That is 2 pi times, what is that n value? 120 by 60. That is 4 pi. That is equal to 12.57 radians per second. Then after knowing this omega OA, what is the VA equal to? OA times omega OA. What is OA? Again 200 millimeters. That is 0.2 meters times 12.57. That comes under 2.514 meter per second. We know the value of velocity of point A, that is 2.514. We want VB, that VB equal to VA by I13 to A times I13 to B. VA, that is 2.514 by I13 to A. What is I13 to A? I13 distance we measured 840 millimeters. That is 0.84. What is I13B? 1.07 meters. Now that is the point velocity of point B. That is 3.2 meter per second. We calculated velocity of B, VB. Next, what is the next objective? The next objective is, what is the next objective? The next objective, we found out velocity of C. We found B. Now we know VA, we know VB, but we need C. The C is connected to point A or point B. That combination you have to take it. Now here if you see, the C is connected to point B, but not point A. That means what is the next combination of? The next combination is BC. Again VB, this BC having link 4, that BC is the link 4. The common eye center for link 4 and with respect to BC is 1, 4. How to look again? VB by I14B equal to VC by point C2, that eye center distance, point C to eye center, I14 to C distance. This is the combination. Okay. That means this here we are applying constant angular velocity ratio theorem. This point B and point C are having same angular velocity because it is on the locating on the same. locating on the same link. That's why we consider it here. In this combination, how to find out again? What is VB by? How it comes? By using VB by I14B equal to VC by I14C. We know what is VB? 3.2 meter per second. I14B, the distance is 0.4 meters. VC is unknown. I14 to C, where is I14 to C distance? That is 0.2 meters. Now VC equal to, what is the VC? 3.2 by 0.4 times 0.2. That VC comes under, that VC equal to the value becomes 1.6 meters. Now VA we know, VB known, VC is known. What is the next combination? VD has to be found. Now D is connected to which link? Which point? Point C. Now we need VC and D combinations. VC by CD combination center. What is the CD combination center is? 1-5. This fifth link, no, CD is the link number 5. Then this link 5, which combination is having? CD connected to 1-5. What is the VC by? I15 to C by VD, I15 to D. Okay, now we have to calculate. We already found, measured I15 to C distance, I15 to D distance. We know VC, we know I15 to C distance, I15 to D. VD can be calculated. The linear velocity of the point D, VD equal to VC how much? VC, just now we calculated 1.6 meters. That VC equal to 0.6 meters. And I15C, that I15C equal to how much? 0.74 meters. Next, multiplied by I15D, 0.5 meters. That VD can be calculated as, it comes under 1.08 meter per second. Alright, in that manner, we have to go for, we calculated velocity of point A, velocity of point B, velocities of point C, and the velocity of point D. These are all linear velocities. Now let me see the velocity of VA, VB, VC, VD. What is VA? How much we got? VA was given. The VA value is 2.514 meter per second. VA equal to 2.514 meter per second. Next, VB. This VB value, that is 3.2 meter per second. VC value 1.6 meter per second. And VD value 1.08 meter per second. When crank rotates with 2.514 meter per second, the linear velocity of the point B increased. That is 3.2 meter per second. Then it comes to point C, it is reduced off of that 1.6 meter per second. And again still reduced, it comes to the slider, that is 1.08 meter per second. Now the efficiency means the advantage, how much it is. If we give the input velocity, in linear velocity is 2.514 meter per second, the output link, that is the slider, having a linear velocity of 1.08 meter per second. It is reduced off of. Okay. So it is reduced to 60%. Okay. 1.08 by 2.514. It can reduce approximately. Now, point is that why it is happening same motion with the same speed, it is not happening. That is the thing we have to find out. That is not there, that portion is not there in our curriculum. But it is very important to find out why it is reduced. What are the reasons? What are the reasons behind? Okay, is it geometry effect? Is it due to friction? Or it is due to some other reasons? So that comes under the categories field of synthesis of mechanisms. That's why this theory of machines, the study of theory of machine is called analysis and synthesis of mechanisms. We have to design the links of a mechanism, or we have to design a mechanism in such a way that we can reach the input speed of the link is closer. The output link speed, the speed of output link is coming more and more closer to the input link speed. And if you want to increase the speed of output link more than the input, what to do? Okay, these are the gaps. We have to work on that in order to find out the design of a mechanisms. Okay, now so far we calculated the linear velocities of the links of the points B, C, D. Now, the next we have to find out the angular velocities of the links. Now of the links, I am telling now of the links AB, BC and CD. These are the three objectives. Now omega AB, what is the omega AB? This is the link AB. Omega AB equal to VA by I13A. We already calculated in this constant angular velocity ratio. Okay, or another formula also we can use. Omega AB is the common for point A and point B. If you consider point B, VB by not I13A, we have to mark it as I13B distance. Then it is 2.99 radians per second. Next, omega BC. What is that omega BC? This omega BC, how to find out omega BC? Omega BC is the common for link BC. That is VB by, what is the common eye center? Link 4, I14. So omega BC equal to VB by I14B. Or another way, anybody can answer. It is also VC by I14C. So VB by I14B or VC by I14C, both are correct. Next, omega CD. What is the omega CD? The CD is link 5. The common eye center for C and D with respect to 5 is 1,5. What is that? How to measure it? Again, if we consider point C, VC by I15 to C, or another formula, VD by I15D distance. We can use any of these two formulae to find out the angular velocities. Now, this omega AB equal to VA by I13A. What is it? VA by I13A? VA we know, velocity of the A, 2.514 meter per second by I13. Where is I13? 2 point A. Already marked I13A. That is 0.84 meters. That is 2.99 radians per second. Next, omega BC, VB by I14B. VB, what is the VB? That is 3.2 meter per second. 3.2 by I14B. That is 0.4 meters. 3.2 by 0.4. That is 80 radians per second. Next, omega CD, that is VC by I15 to C. That is VC is 1.6. Substitute over here. That is 1.6 by I15C, 0.74. That is 2.16 radians per second. Now, from this, we can interpret some of the results. Some based on these values. The values here. Now, omega AB having more value or larger value compared to, this omega BC having larger value in comparison to links, angular velocity of the links AB and CD. So this BC is having more value. That means VB. That's why linear velocity of the B having higher. This VB is higher. Because of omega BC is higher value, that VB having B and C. Yes, point B is having higher values. Now, VCD, this D is 2.16. The lower value, that's why VD becomes lower value. VC by I15C. Okay. In that manner, we have to find out, alright, angular velocities of various links. Suppose if you want omega AB, BC and CD. If you want to find out the linear velocity of the D, yeah, we calculated already linear velocity of the D. Any other combinations we can calculate. Okay, this is what locating eye centers of a given mechanism, and also we found in this session or in this class linear velocities of the points B, C and D, and also angular velocities of the links AB, BC and CD. Okay, in this manner we have to calculate. Again, let me summarize in this problem. So here, whenever any problem comes, how to start? We have to redraw the configuration diagram into your answer script. That is step 1, as it is. How to redraw? Again, here 1.35 meters was given value. Is the huge 1350 millimeters. So how to make it? What to do? You have to take a scale, either reduction scale. We have to follow here reduction scale 1:10. We can take it. So by using reduction scale, we have to draw the configuration diagram. So in order to draw the configuration diagram, we need instruments, mathematical instruments such as compass, protractor, pencil, eraser, okay, are required, or 2 set squares are required to draw parallel lines. But in this case study, we don't want to draw any parallel lines. So compass, pencil, scale, eraser is sufficient. Please try to purchase not small compass, mini compasses, the larger size, large compass, because we have to extend at least 150 millimeters. It should be extensible. Otherwise, we cannot more than 10 centimeters. It cannot. Mini compass box, we should not. It is the maximum. Large compass box, we have to purchase it. So after drawing the configuration diagram, by taking the reduction scale, we have to redraw the configuration diagram. After that, we have to find out the number of eye centers. After finding the number of eye centers, with the help of the formula, after that we have to know what are the eye centers are, what are the combination of the eye centers, by using links versus eye center table. After drawing those eye center table, we have to go for circular diagram. That circular diagram requires in order to how to locate the eye centers in what combinations. Then we have to locate the required eye centers. Suppose we have to locate all the eye centers. Yes, we have to locate all the eye centers. Generally in this problem, they did not ask us, yes, locate the all instantaneous centers was asked here. That means it is a 6-link mechanism. So we have to locate all the eye centers. But in this answer, in the solution, we did not go for all the eye centers, but we have to locate. After locating the eye centers, we have to go for the combinations based on the objectives. Those relations constant angular velocity ratio relations or linear velocity ratio relationships, we have to make it. After that, before going to this decision making, we have to measure the combination. We have to measure the distances from icenters to the required points. Then we can calculate very easily. That's what we followed those steps in this problem to find out the velocities, linear velocities of point B, point C, point D, and angular velocities of links AB, BC, and CD. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.